another example, which is on AB plus AC. So what happened, we can see over here there is a multiplication. Two multiplications mean 2 and get. Again, I repeat, you have over here 2 multiplication. This is 1 multiplication 1, and there is another one is multiplication 2. So normally, multiplication is using and get. So you have 2 and get, and then in between you have another, which is adding process of operations, which is normally you use the or get. So first of all, maybe because you are a beginner, going to start from your left. So you will have a b, which is a multiple with b. A dot b, it will be like this: a b, and then there are output. And you have another one, which is a and c. But if you can see here, this is what happened. And then you have another one is o get. You will put like this. This is your o get. This one is a b, a dot b. I like to have dot, so I know it's multiplication. A dot c, and then I will get the output from this one is a b plus a dot c. So this is how it happened. But you can also simplify over here when you see there is a similar in input. You have a input. So what happened here, no need to do like this. You drag the input, you put it here. Similar, if you are using the simulator, you can just drag it and using the similar input over here. Same. So next, which is on the truth table. So later on, you will see that from your Boolean algebra, you will get 2. Let me show you first on that. Later on, we will go back. But this is what you need to know, which is from your Boolean expressions or your Boolean algebra things, you're going to get truth tables, and another one your logic circuit. So that's why you need to know on truth table. From your truth table, you can have the diagram, timing diagram, and this is the circuit. Whether it is a basic circuit or combinations, it depends. So what happened if, let's say, this is just example, you're going to get the truth table and then the logic get from the equation were given. So sometimes you were given the circuit and vice versa, you need to come out with the Boolean expressions, or sometimes you were given the Boolean expression, you need to come out with the logic circuit, vice versa. You can see over here, similar to truth table, if you sometimes you are given with the truth table, you need to have the Boolean expression. If you have a Boolean expression, you can also get the truth table. So back to our discussion. So over here you have the examples of this truth table. You were given A dot B dot C and A dot B dot C using truth table. So what happens if you have A dot B, C, whether it is similar to here or not. So you can also come out with your circuit. You can see over here you have 2 AND gate. Similar over here you have 2 AND gate. Let's say I draw it for you. I have A and okay, wait, I did it first. I have A. This one is A, and another input is B dot C. From here I know it will be a AND gate. It will be like this. So this is the circuit for this Boolean. And I also have this, which is I have A dot B, which is A and B, and then the output will be A dot B, and I have another AND gate. This one is C, so it will be A dot B, and then it's C. So it's represent like this. Whether it's similar or not, the output for the output here. So you can have your two tables. You can using this circuit to show it, whether if let's say this A is 0, and then this is 0, and then this is 0, what happened to here? So you can play around with your truth table, and you can also draw the circuit in your this simulator and have a look what is the answer for all of this. So here is this is just an example for you. Over here, if let's say you have A dot B, you know this is multiplication for AND gate. So wherever the input, if let's say the input is 1, both input, BOTH, both input, which is 2 input of this is 1, then you get 1 for the output, but the rest will be 0. So you can just throw it 0 until you have A and B equal to 1, like this. While you have another one, it's because you have 3 input, because you have ABC. So that's why you have a possibility of 0, 0, 0, and then 0, 0, 1, and then 0, 1, 0. Why this happen is because this is 1, this is 2, this one is 0, this is decimal, this is the binary. Where is your binary? This one, 0, 0, 0, 0, 0, 1. This is binary, which is represent as 1. 0, 1, 0, which is represent as 2. 0, 1, 1, it's represent as D. 1, 0, 1 is represent as 4 until you have over here 7, 1, 1, 1. So this possibility of if you get having 3 input, going to have 2 to the power of n, isn't it? Minus 1. So you have over here 3, 8 minus 1, 3 minus 1, 8 minus 1, so you get 7. So over here it is 7, something like that. But what I want to show you is the possibility of 3. If you have only 2 input, you only have the 4 possibilities, isn't it? This one is 8. So you have, let's say, 0, 0, 0, 1, and 1, 0, and then 1, 1. Only this possibility for A and B, 2 input. But if you have 3, you need to have another 0 over here. So you need to from 0 until 7. Then you draw another one, which is BC. Still again, you need to have 1 1 for B and C. So over here is 1 1, and then here is 1 1 for BC. You will get like this. You try to draw it until you get here. So you can see what is to prove over here is A dot BC equal to A dot BC. So whether here similar or not. So you can see all is similar until the end. So then you prove it correct. And this is the part that you need to remember. 12 Boolean Algebra rules. Last time when I'm studying for my degree, too long times ago, I just remember I did not understand it fully on representations of the circuit, but I think it's wrong. My method is wrong because I just remember without fully understanding. So now I want you to full understand on all the rules before you can memorize it, because the most important thing is to understand how come you can get all these rules. So first rule is on A plus 0 equal to A. So over here, this A can be B, can be C, can be X, can be Y, can be anything variables, as I mentioned. As long as you have the input, so this is input, plus any kind of zero input, you will get the similar output for the input A over here. But this is for adding. Let me draw adding, right? So it is O. Let me draw the O circuit. Over here, I have fixed it to be 0. But our A over here is variable. Variable can be 0 or 1 only, right? So there is a 2 possibility of my A over here. Then it is the output. What is the output? I still don't know yet. So let me try one by one, which is only 2 possible, so it's quite easy. Let's say I have A equal to 0. So this is OR gate. I know if 0, 0 input, the output will be also 0, isn't it? So if let's say my input A, another possibility is 1. So 1 plus 0 for the OR gate, it will be 1. So what happened here, I can see my output is similar to whatever happened to my input A. So I assume that whatever input A will be having similar, so the output will be also similar to A. So that's you get your rules number 1. So later on we will see there is also like this. But first example, this one as I show you the basic, later on you will also do it. But the first things that is want to prove the examples here in your 10. So what happened, you were given the truth table first. Let's say we look into the scenario of truth table. You have A, B as your input, and then because you have A and a variable B, and then you have over here addings, mean that O, and there is a multiplication which is AB. So you have AB over here, you have A and B as input, and then what happened here? Your output. What is going to be your output? This is your output, which is A plus AB, because this is the equation. So from here, let you draw the possibility A and B because there is two input only for possibility which is 0 0 0 1 1 0 1 1. So you have 0 1 2 3 for the decimal, and then this is the binary. Is it? So after that you will do A plus B, A multiples B, which is AND gate. You know, for AND gate it only get 1 as the output if the both input is 1 also. So you will get only here as 1. And then after that you having the adding process over here, means that you will add A. So you delete this one because you want to refer only A and A plus B. So A plus B, 0 0, you will get 0 0 0, you will get 0 1 0, you will get 1, because this is O, or adding. As long as you have one input, you will be having 1, so you will get 1 as the output. Just remember that. And then 1 1, you will get 1. So you get this kind of output. Let's check. It is similar to the A, right? So this happened. A plus AB equal to A. That's why these rules for Boolean algebra, for rules number 10, are come out from these two tables. And you can also understand this by using the Boolean over here. Let's say you have A plus AB equal to A, and then this is mathematics, which is I put here, it is 1 B, isn't it? So after you do a mathematical, which is you summarize this, you will get A 1 plus B over here. And from here, 1 plus B, what happened? You will put it into our rules number 2. A plus 1 equal to 1. Whatever variable here is similar like this. 1 plus B, you will get 1. So that's why you will get 1 here. And the answer is A dot 1. You will refer to rules number 4. Then you get A. But all the rules, we will prove it after this. But after you memorize and you understand, then you can implement all of these to summarize the Boolean algebra. You need to summarize later on in your final exam. There is also question for you to summarize the given Boolean algebra. Sometimes it's quite complicated, so you need to refer to your rules of Boolean algebra. So I hope that you can hear me clearly, because I still on my earphone. Okay, I continue. Only I take off my mouse. So that's the limitation of using MacBook. I really don't like it. Okay, next, what happened? We look one by one. Rules number 1 over here, as I mentioned, we already deal with it, which is this one is OR gate. You have 0 and everything is similar, you will get A plus 0 equal to A. This one we already proved, right? Okay, rules number 2, similar circuit. So nothing complicated, only that you just change the input over here as 1. And I already informed you that there is only 2 possibility, whether it is 1 or 0 for the input. So A will be sometime as 0 and A also can be 1. But what is the output? If let's say A is 1, the output will be 1. But if it's A0, the output also will be 1. Because of what? This is OR gate, and whatever, if let's say you have at least one input having one digit, so the output also 1. So what happened is you can get the output whatever input given for the variable A, as long as you have 1, which is you plus 1, like this. So you plus 1, which is you having 1 over here, so you will get equal to 1 for your output. That's why you get A plus 1 equal to 1, because whatever input, whether it is 0 or 1, you will get 1 also. Is it clear? So we move to another example. Not example, our rules number 3. So this is multiplication, and I know multiplication is using and get. So don't complicate it yourself, because it's easy for you to remember. As I mentioned, you're just dealing with or and get, and later on you will also learn on not get. So 3 basic get only that you will apply in your Boolean algebra. And get is multiplication, so you have A dot 0 or A multiples with 0, you will get 0. This is also similar with your mathematics. I don't know what if you didn't understand. Okay, so you put here your AND gate. This is your AND gate, and you have 0 as another input over here. This is fixed because it stated here this is 0 for another input. And as mentioned also, A will be B, C, D, X, Y, Z, any variables, but all the variables have 2 possibilities only, whether it is 0 or 1. So over here you have 1 example, and then whenever you multiple with 0, you will get also 0 as your output. And then you have over here 1, and then this is also still 0. This is 0, and you multiple with 0, you will also get 0. That's why you can conclude both input for A will having the output 0. That's why you get A dot 0, you will get 0. That's rule number 3. So you already proved it correct. And then rule number 4, still under multiplication and get, similar, only you change the another input to be only 1. So you can see over here, as again, I just repeat again because I don't know whether you still remember it or not. Sometimes looking at your marks, I feel worried because there is person that getting full mark, and there is a person that get very low marks. I don't know, you just having same class, same slides, same videos, same books. Only depend on you whether you want to learn it or not. It's your own effort. So please make sure that you fulfill all your time to study. After you finish study, you can just focus to do anything that you want. You want to play PUBG, you want to play then I start mumbling again. Okay, focus back. Sorry. So here rules number 4, you have 2 possibility, which is 0 and 1. When I have this, you can see that whenever for AND get, whenever both input you have 1, then you can get the output as 1. The rest will be 0, so you will get like this. So what we can conclude is it's similar to A. See, If A is 0, then output also 0. If A is 1, the output is 1. For this scenario number 4. So I can conclude is whenever I have A dot 1, so I get A equal to A. So I prove the rules number 4. How about rules number 5? It is adding. Adding, as I mentioned, it is OR get. OR get. This is a basic get. Please remember the functions of this OR get. So you have 4 possibility, I think, but because of you have this kind of variable which is similar variables, which is A should be have 2 possibility only, which is whether it is 1 or 0. So similar also here. So you have 2 possibility. If A 0, another A also will be 0 because it's similar variable, right? So sorry, 0 0, you will get the output as 0, and then 1 1, you will get output as 1. So you can see your output similar to your input A. That's why you will come out A plus A also equal to A. So you need to memorize it, all the 20, not 20, 12. Sorry, I add another 8. 12, uh, 12 rules for your Boolean. So please remember all, but before you remember, you need to understand it to prove it how you get those rules. Then rules number 6, which is you have A plus A bar. So as again, you have only 2 possibility whether it is 0 or 1. So you put it here, and adding process is OR get. This is OR get, and you have 0 first for A, and your A bar will be 1, isn't it? So you will get the output as 1, and another possibility A equal to 1. So your A bar will be 0, still you get 1. So you can conclude that A plus A bar equal to 1. So it's proof. Another one, which is rule number 6. For rules number 4, it is the multiplication. I don't know for the one that already mastered with this one, so you will feel boring because this is just a simple logic get. But I still need to go through one by one for those that still like having their time to get understanding on this basic. So rule number 7, you have AND get because it's a multiplication over here dot, and then you have A and A, which is 2 possibilities, 0 or 1. So if A and A, it will be similar. Like this, you have A and A bar, so you will have the opposite for both. Because it's similar, you have 0 0, you will get 0, 1 1, you will get 1. So your answer over here, you can see if input 0, output will be also 0, which is input 1, you will get the output is 1. So it's equal to A. So prove another rules number 7. And then rules number 8, you have over here a dot a bar. So it's sometimes it's quite complicated for you to remember because there is a plus a bar. Now you have a dot a bar. So yeah, you still need to remember it. I faced it before. It's just a process of learning. So just admit you are a student. I need to do this. I need to learn for yourself, for your parents, for your family, for your future. When you want to become someone in your future, you need to do it now. So our present is representation what we're going to be in our future. So take note on it. And rule number 8. I don't know what happened to me this night. I like to mumbling. So rule number 8. You have A and a bar. Of course, it will be opposite. It is a AND gate, and you get the outputs. If let's say 1 and 1, then you will get 1. But there is no possibility like that because you have opposite input A and A bar, so you get 0 in any kind, vice versa for your input. That's why A dot A bar you will get a 0 because this is a AND gate. Then next one, here come, I told you, you will also put it and play around with NOT gate. So for your NOT gate over here, you can see that you have A bar, not A bar, A bar bar. Because you have over here 2 time bar. So check it carefully. You have A bar bar equal to A. Of course lah. This is very simple rules. No need to memorize because A bar is the opposite for your A. For another opposite will be A bar. So you have only two possibilities, 0 and 1. So let's take a look into the circuit. So bar will be represented as NOT gate. Don't see my writing, it's very ugly, I admit it. So over here you have 2 NOT gate. So NOT gate over here, why you have 2? Because you have 1, 2. It's easy, right? So over here you will have A as input. Why? Because you have 1 only at your input side, and then you will have two possibility, A as 0 or A as 1. So you will doing the bar first, it will be having 1, and then you have another bar, you will turn it back to 0. So it's similar to here. If another possibility is 1, so 1 you bar, you will get 0. You bar another 1 which is not inverse, and then you will get 1. So it's similar to your input. So that's why if you have 2 bar you will get similar to your input. So next, rules number 10. I think this video is already occupied longer than I think and imagine. Okay, rule number 10, 11, 12. You can also prove it by using your Boolean Algebra rules. This is the examples on Boolean Algebra. Over here you have A plus AB. So you will get A, and then you have this one factoring factor, which is A plus B. A plus B, you go back to rules number 1. Rules number 2, sorry. Rules number 2, A plus B, you will get equal to 1. So that's why you get A dot 1. And over here it's rule number 4, which is A dot 1. You get A. That's why you can simplify here. You get A plus L bar. You get A. You can also draw your Boolean circuit. You have operation multiplication, adding operation and multiplication. So you have only one OR gate and one AND gate. So let me draw it. This one I assume I don't know how to draw the circuit, the method or the flow that correct. I just looking into my equation over here. So I have A as the input for both AND get and OR get. But before that, I have A plus, means that over here it's happened at my OR get. So I have here A, and then my input, another input will be A dot B. So that's why I will get here A dot B is AND get. So I put it here. This is A dot B, and I know this one is B. I have another input B, and my input A, I put it here. Then I get the output over here is equal to A. You can play around with the digits. So this is the value 0101. You check it, then you see it's similar. Rule number 11. You can also draw your circuit just to prove. Try to look into, but over here it's give the example for you to play around with your existing Boolean algebra law. So over here you can have A plus A bar B equal to A plus AB plus A bar B. What happened? Let me see. A plus AB plus A bar B. If you over here is directly, you can see over here, if let's say you have rules number 10, A equal to A plus AB. So whatever happen, you can see over here, this is A. That's why you use this rules number 10, you put A plus AB over here. So if me myself, because I want to be like you, which is I want to teach you from someone beginner. If I just using my knowledge, means that I'm too advanced. You cannot jump into whatever happened here. Somehow it's like this. How come it's jump to this? So that's why I put it the scenario. What happened here? So I put it here is A, and you will use the rules number 10. You apply this one, which is A plus AB, you will equal to A. So you will put A as this one, and then you plus A bar B. So you will get this, no need for you to put the factor anymore. So over here, what you happen is A also equal to A dot A. This is rule number 7. So that's why later on you need to prove all these steps, because sometimes you were given the question, please prove this equation is similar to this question. So all these steps, this step number 1, 2, 3, 4, 5, maybe you have all this one, total is 5 marks just to prove. So that's why you need to have the ability to play around with existing rules, then you convert it all to get the answer, just to prove. So over here you get A dot A, you will having a similar A, and you just drag it below A B, and you have similar also for this part. Now when you have this, you can also use rules number 8, which is adding A bar B equal to 0. Where is it? You can see over here, whenever you have A bar AA plus AB, this one is you already make it longer, because I think there is a mistake over here, it's not fully show you on this part. So maybe you can have a look into this. You can have a bar and then a dot b bar. I think let me show you the rules. So this one, rules number 8. So over here, a bar dot b. Sorry, this one is rules number 8 over here, adding a dot a bar, because this one is equal to 0. You just add this one to here, because there is nothing effect if you just add 0. If you add rules number 1, which is you put a bar a plus ab over here, you get 1 plus b, which is 1. So you put here, then it will affect your equation. But when you use rule number 8, you just adding here, it's nothing happen because it is equal to 0. You just want to add it because you want to make it similar, so you can factoring it or summarize it later on. Because over here you have a, and then over here you have a bar and a bar. So you have b and b. So you want to make it look like similar, so it's easy for you to factorize this later on. So then you will having the factoring process. This is the mathematic equation. You need to factorize it, and then you get a plus a bar, and then a plus ab, a plus b, similar to this one. So it's quite complicated. That's why I mentioned for you, you need to have all the ability to understand the equation, and you need to apply it into the equation to just to prove. And then you get over here a plus a bar. You check back to the rules, a plus a bar, rules number 6, it is equal to 1. So you get 1 over here, and then this is multiplication, of course, for your factoring, a plus b. So whenever you have a 1 dot a plus b, you will get also similar, which is rules number, let me check, a dot 1 over here, rules number 4, you will get similar, which is a. So this is rules number 4, and you get a plus b for this one. So you were not given just the question, but the question will be asking you for you to prove. You were given this Boolean algebra, and also you were given it's equal to a plus b. Prove it. So this is a step by step how you're going to prove. You need to play around how you can get a plus b. You have the a bar, but how you going to delete it because you have a plus b. So you need to play around with all the 12 rules, and the last rules is a plus b factorand, which is multiple a plus c. You will get a plus bc. So similar, which is you going to using the distribute law. It is your mathematic equation and mathematic program for you to remember. It is on your primary school, and you make it longer like this, and after that you will play around with the rules. So over here you will get a dot a equal to a rules number 7, and then you can have like this, a plus ab. You will get using the factorize, and a b plus bc. You can also factorize later on over here, but depends on what is the similarity for the output and also the input were given the equation. And then you apply the rules number 2, you will get a dot 1 plus ab, which is this one. Y1 over here is rule number 2, 1 plus any input, it will get 1. So AB plus BC, you use the factoring also again, and you get A dot 1 plus BC, you use rules number 2, and then after that later on you will use rules number 4 because of A dot 1 over here is A. That's why we will get A plus BC. You need to do many exercise in the derivations and also factorizations, and to implement all the 12 rules. You need to play around with it. So it's not just having a simple equation then you can get the answer, how to prove it, etc. You need to make it like familiar with all the equation, and there is a possibility for you to get what as the answer. Maybe I will give you extra example how you can get and prove from the input and also the output. So that's on the 12 rules. I think that's long enough for you to get the input. If I add another one, which is under the Morgan theorem, so you will be complicated for your brains to take on. For me, I take step by step to learn, to memorize, and to understand. The first thing I need to do is to understand first. So let me give you to understand all the 12 rules first. Before you jump to another theorem, which is you need to play around with another get, which is and no get. So maybe for next class, we can look into our De Morgan theorem. So if let's say you already master with all these 12 Boolean rules, so you can just straightly jump and do a revision before I start the class and also doing the video and etc. Later on it will be complicated. So you can see like this. You will be given the equation. Sometimes you need to represent it in logic circuit. Sometimes you need to come up with also truth tables, but the ones that you need to derive is much complicated because you need to play around with all the rules. So I think only that for this video and for this class. Later on we will straightly jump into our De Morgan theorem. So thank you for your watching, and please try to do as many revision as you can. If you think that my notes is not enough, then ask me to give extra notes, extra video, extra example, extra exercise. You are a student, then me as a lecturer, I like a seller. I sell my knowledge to you, and you as the student, you need to request, because customer is student. As a customer, you need to request for something, which is, let's say you say it is not enough, so please request me. Maybe my teaching is not really understandable for you, so you also can request me. Maybe you need to having extra classes, maybe any extra exercise, then just mention it to me, so I will try my best to fulfill, because I'm not just being as a lecturer to comply my timetables. Let's say, okay, I have class on Monday and Tuesday. Okay, I have about several chapters, several modules to finish. So I just give, teach and teach, and at the end, it's depend on you, depend on student whether they can score or not, because that result is not giving me anything. True, I didn't get anything if you get A plus or if you get full score. Did I get anything? No. But I will feel like, oh, I'm proud. The students come from my section. I know her. I knew her. I knew him. So it depends whether it's her or him. And I want my student to success. I don't want my student to fail or something. That's why when I check the result for your test one, I feel like, how come you cannot do this? How come you cannot do that? How come there is a student score higher? And what happened to the student that cannot score? What did I'm doing wrong? I'm not asking what happened to my student, what did they did wrong. No, I'm asking myself, what did I did wrong? Because did I teach you a wrong thing? Did I'm not fully give you all the informations, all the theory or notes or whatever knowledge that you need to apply in the test? So that's why I'm asking also myself, but I also quite confused whenever there is a section, similar method, similar approach, but still huge indifferent. And when I try to ask, maybe some of the students just saying they did not study well. So is it my wrong? Still, although they said like that, they did not study very well for the test one, but still I feel like, why are you not interested in study with me? Am I teach you in a boring term? So how can I help you? What is the method or approach that you want to request for me? You request me to do all the online classes, but you need to also think about others. There is also student did not have good facilities in internet. That's why I cannot do all 2 hours straight for just our online class. And if you watch this video also, it's already more than 1 hours, and you also feel like tired, boring sometimes, right? So it's not supposed to be like that. So how? Please suggest to me. Maybe if you don't want to put it in the WhatsApp group, you can PM me directly. How can I improve my teaching? So you also can promise me whenever I try to deal in whatever your request, you also will give the same output, which is show me the result, maybe for your test too, maybe for your lab or assignment, that you improve your study. Is it okay? So just push me with your WhatsApp, how to improve my teaching, how to help you to get better result in your digital logic. Because the first thing that you need to know, the subject will be getting tougher and harder, followed by the year. For now, it is only first year for you, and this is the time for you to score for your pointer. If you get low pointer in the beginning of semester or in the beginning of the year, so it's quite hard for you to improve your pointer later on. So please start from now, and please set your mind, you are a student. Your responsibility is to study. There is many other interruption. I also being at your place last time. I play with Facebook at the time just come out a lot. I study only whenever at night. Sometimes I play too much with a sport, and then I also like playing a computer game at that time. But I set my mind also at that time. I have a aim to buy the PS video game, but then I know that when I addicted to game, like last time I too addict with PUBG, so I just give my time for playing only. Sometimes is occupy my time, my sleep time also. So please don't be like me. Please try to put and set yourself, okay, let's say you have 1 hour only for your Instagram or your uh, Facebook, because if you can take note that you having too many times, similar to me currently, if I start surfing on my phone and I say, okay, another 30 minutes only, then after that I said, oh, there is another news, there is another interesting story to see. Until sometimes I cannot realize that it's already occupying me 1 hour, 2 hours, just only surfing and playing around with the internet in my phone. Similar to you. So maybe you can just use your phone to another better things, surfing for information, surfing for your subjects, not only for this digital logic. So again, I bebel lagi, right? Because I feel a bit frustrated for student that cannot do well. Please take note that your lecturer, not only me, they very keen, and also they really care on your mark. I don't know whether there is too selfish that they didn't care about their student, but as my knowledge, all the lecturers care whether their student can score or not. It's sad when the student cannot score because I'm the lecturer. Let's say like this. Oh, my student fail. Let's say my student get the lowest in the section for digital logic. So I feel really bad, and I feel like why I cannot get better, similar to other lecturer. They get all good for their students. What happened? What am I wrong? Something like that. So please remember that not only you want to score, but also me, I want my student to score also in digital logic. So whenever you have a question, don't hesitate to WhatsApp me. And again, I have problem with WhatsApp. I have a lot of WhatsApp because that's the only number I have for my personal teaching and for my business. So sometimes it's messing me around, but I don't want to have another numbers or another phone. It's not my time anymore. Last time when I'm student, I can have 3 phone, 3 numbers. I don't know what happened to me last time. So now I cannot. I don't want. I just stick with one number. So that's why sometimes I cannot see your WhatsApp. Sometimes I already open and I want to reply, and then I already forgot because I also have any other things to do. Sometimes I said that, oh, I have an important WhatsApp from my student, but when I go through again, I check one by one, I really cannot find it. So maybe if I did not reply, don't feel like I didn't care about your WhatsApp. You can push it again, re-WhatsApp me. just saying, oh, I WhatsApp you, I'm waiting for your reply, like that. So calling anyone, is it okay? So thank you for your time, thank you for your watching, and meet again in next class. Goodbye.